Hello, welcome to another episode of the Raccoon Stealer Analysis, Part 3. Today we're going to be looking at the communication between Raccoon Stealer and the C2 and looking a little bit into the depths of that. I won't be going into too much of it. I know I've talked about that quite a lot, but this time I will be looking at the initial communication, and of course when it goes closer to the stealer parts, I will not be going anywhere near that. So this is mostly to understand how you can modify stuff, how the developer probably is modifying stuff, and how they developed a builder. I think I've touched slightly on it before, but just to make it a little bit clearer, for researchers and if you're playing around with malware and also internal threat intelligence teams, emulating C2s and doing that yourself and trying to understand the protocols for defending is actually really important for internal threat intelligence teams. Yeah, really important. I think we got to around here last time from what I remember. So we had that XOR loop, then we started looking at these base64 encoded strings, which is really kind of crazy. So what we're going to do is we're going to go off from here. So I know we've gone through this. We've gone through the defining of it. We've found it interesting to see the base64 strings decoded. And now we're going to go into what happens after they've been decoded, right? That's the interesting part. So we've got all these crazy subroutines that I'm skipping by, and everyone's going to hate me because, they're like, how do you know that and stuff? Well, I'll just do this until something interesting comes up. So we see this. This is where I was going through these subroutines, and then this re-emerged. Now we've seen this before, but this came back up. So we've had the base64 strings happen, and then we had this re-emergence, which is really interesting because once you get this re-emergence, you're like, why is this bringing this back into the phrase? So we've seen that come back, and then we get this really interesting call that I've already sort of spilled the beans on. But if we go on to it, we see that in the stack we get here. You see that the calls where we've got the reference to the weird string, I'm going to call for now, and then we've also got, if we look at this one, following dump, A9, A1 here, and that null terminator. So this is our decoded base64. If you remember the Q, I've not got that up, so I'll just get this up to jog your memories. What we were looking at, we were looking at the QS string here. So that was the base64 version of it, and it just so happens I've talked about this quite a lot in the smoke loader video. So if you haven't seen that, go onto the channel, look at the smoke loader analysis. It's RC4 again. Crime, especially when it comes down to loaders or stealers, they love using RC4 for some reason. I guess it's really easy to implement rather than importing AES or trying to use that and code it yourself or copy and paste AES or other alternatives. RC4 is relatively easy to implement, whatever its vulnerabilities and fragilities with cryptographers. So I identified that this is RC4. I could go through it, and if you're really interested to see the Raccoon Stealer analysis of RC4 instead of the smoke loader, there won't be too many differences. It could be a small little video for you guys, but I just don't think it's worth it, so I've just skipped it. But the identification of it was very similar in some ways to the smoke loader analysis. So if you're interested in that, go for it. So we've identified from these two here that we've got what looks to be the key, right? I mean, we could look at the rest, but this is the biggest sort of defining one where you're like, okay, so we've seen that sort of decoded and defined before we got here, and then we've got the decoded base64, which is after that as well, and now we're using this call implementing both, which I've been able to track through the debugger. So once we do that, the big thing as well is once we hit that, there we go, we get this URL, which is really interesting. So if we use cyberchef to go through this process and confirm what happens. So I've got the QS string there. I've base64 decoded it from base64, and then I've just put it to hex. So we've got the same thing that we can see in the debugger. Now what I'm going to do is I'm going to use RC4. So we've got the input format is going to be hex. The output is going to be UTF-8, and we need the passphrase to be hexadecimal. And so with that, I could put it to UTF-8, but with that I need the key back. So what I'm going to do is I am going to go up from a previous breakpoint. I know that this is where it is set, so what I'm going to do is I'm just going to set a breakpoint here on the length check, and I'm going to restart the binary. There we go. And then I'm just going to single step for the moment, go onto that where the final results are happening. Lovely, we've got the asterisk here, so we can copy out these lines when it's complete. So I'm now going to remove the breakpoint and get to the other breakpoint there, and then copy out this and clean it up. I'm sure there's an easier way of this. I could do the UTF-8. The reason why I'm not is to be definitive, if I'm honest. I'm not comfortable with right, what is that? That is the last one's 24. So this is where it goes all wrong, and I'll need a hex editor to confirm, just to make sure. I believe the $sign's 24, so I'll leave that there. But in my opinion, I'm far more comfortable with a hex editor. I think it gives you a more definitive than the strings. Strings can be sort of, you don't see the full, like there can be various versions of the representation of what looks like a period, but it can be something else. So, 0020, for example. So I prefer to just do hexadecimal to be definitive, to know what you're looking at. And what I'm going to now do is I'm going to put that into a hex editor to just clean it up a little bit to see what we've got here. So we've got the null terminating string that I don't want. We want the R, from what I remember. We can actually go beyond this back to the break. Did we breakpoint RC4 decrypt? We did. We'll go there. And we can see we see the R, and then we've got the null terminating string, right? So that sort of makes sense. And then we've got the $sign. We haven't got the B, which makes sense as well. So I'm now going to just enter in the hexadecimal representation of that, and hopefully we get the same result. And we do. Cool. Lovely. So with that, what's really cool is that we can now modify this binary, because we understand the whole what it's trying to do. Now, normally you would have problems in binaries sometimes with the length, because essentially, if you change the length of a binary, it can have problems. So what we want to do is we want to have a little look at this and see if we can. So what I'm going to do is search for that string that we had, which was QS, if I remember. Let's go back to references, Q and then capital SV. So SV. There's more than one of those. Okay, this was less fruitful than I thought it would be. There's a lot of QSVs. Okay, let's QSV. You know what? I'm just gonna, that would make a lot more sense if I just did that. There we go. So the interesting thing about this is, if you look, we've got a load of 20s, right? Now, my interpretation of this is how they've made a builder, is they essentially support for a base 64 encoded string that is this long, and that what they do, and what we've seen before, is that they chop all the 20s and then just use what's in that sort of, so it's trimmed it. There's a lot of, in programming languages, there's the function trim where you get rid of the spaces or whatever. So this looks really good. But we got the null terminators essentially here. We've got 4, is that? Yeah, 4 null terminators before a new string. So some spaces there. But on my interpretation of this is that we can write a new URL and not really be worried about the length, because we've got a lot of length space here. It's just a theory, but I've got a very strong confidence towards it. So with that as well, that means that's really good, because we could emulate the telegram.in here in the host file, which I can talk about in other times maybe on the tele.in, but we've got the HTTPS, using a web server with HTTPS, emulating it. It's a little bit of it's just aggravating. If we can modify it to use HTTP, where it doesn't, there isn't actually any SSL functionality per se in it's using WinHTTP, so we don't need to worry too much about this. If it was another variant, it would be, and this is where malware analysis is a little bit annoying to really make videos for, is because there's endless possibilities into different variants. So when you're teaching something like this, it's like, well, in this case, yes, but if there was this. But in this particular case, which is annoying, I know, but it's really cool. So we can just modify this because we've got this easy sort of, there's the ability to change the length of this string because we know the full format now, and it can be quite easy and nice. So what I'm going to do is I'm going to do just that. I'm now going to reverse the process. So I'm going to get a new tab. I'm just going to copy and paste this. I am using a local host version of cyberchef in Internet or Edge, so this is going to be interesting. I want none of that. I want just the RC4 version. I want the input to be UTF-8 and the output to be base64. We want the same key, and this time I'm going to do HTTP localhost and then /index.php. And what we can do, really, what's really good is we can actually just verify this. So what we can do, new tab, have the same process of what we've had here. So what's cool about cyberchef is it has all of the instructions in its actual URL, or URI should I say. So what we can do now is we've got this version. Let's just test our output version here. See, I've changed it to HTTP here. Is we can just test this one with the same process that we've tested before, and it's working. Lovely. So what I'm going to do at this point is I'm actually going to, from here, I'm going to save this as video modified. I don't know why we've got the full path there. That's quite strange. Video modified. It's cool because we've got this in the debugger, so it's going to be upset if we do that because we've got it in a process in the handles there. So with that, what I'm going to now do is from the starting string, where I know the string starts, we've got the null terminated here. From this 71, what I'm going to now do is I'm just going to put a load of 20s. Oh, it'd be good if I could type 20, isn't it? That would be helpful. This is just to make sure that we start from the start, and the length from here doesn't really matter, because what we're going to be doing is now we're going to be copying and pasting, and there's multiple ways that you can do this. This is my way, but we can actually build on from this as well and create our own little builder, and put various configurations in there for internal use, which is really good. I mean, there's the bad side of it as well, which is why I don't go too much into this, where if a criminal had so much resources and was inclined, they wouldn't have to pay for Raccoon Stealer. They could actually just reverse engineer, modify it themselves, and not pay for it, and put some updates in there, change their URL. So yeah, what we need to be here, and that's why I don't go too much into this for that exact purposes, is that I don't want to give too much away, but I want to help analysts and internal TI teams, and parts of it, unfortunately, you have to work out yourself. That's unfortunate, the world we live in. So with that, we've got the hex side of HXD, and then we've got the decoded text size. So that's where I'm going to be pasting. I'm going to be doing a paste right, so we don't remove or change the spacing, because binaries get very funny about that. I'm going to do a paste right. So that's what's so cool about the Raccoon Stealer here, is that we can just modify this doing a paste right, where we're just modifying the length of our text, which is only, and we're not changing the length. Hopefully that makes sense. So with that, I'm going to do the paste right. Cool. As you can see, that was not changed because we didn't change the length. We just wrote over the values that we needed to. I'm now going to save that, and I'm going to put that in the debugger. Cool. So video modified, just to test it out. So we know it's near that QSV string. So what I'm gonna do is I'm just gonna breakpoint on that. Although we haven't got that QSVV, that would be. Oh, we have. What am I doing? What am I doing wrong? Let's have a look. Oh, I've not got 2 equals this time, so I've got 1. So 4m equal to search for that. There we go. So we know that that is going to be used. So we'll breakpoint on there. We can see, of course, again here. So what we're going to do is we're now going to run it. We're there. We're now going to just verify it and see what's going on there. See if we get that localhost and that correct decryption, because that means then we've successfully modified it and it will contact localhost, which is really cool. So with that, let's have a little look. We're looking for the RC4 decrypt. I'm very, very worried that a live demo is not going to work, but it should. Everything that I know about reverse engineering, this should work. So yeah, let's have a little look. Wow, there we go. The E04 is the RC4 decrypt. See, lovely. We've got the local host. We've got that. Let's start up a web server. Now, I know a lot of people judge me on this, but I do still use XAMPP. I've used it since 2013. It's sort of one of those things where, you know, you talk to someone who's like in their 50s, 60s, and they say, you know, they still write in BASIC or COBOL or something. You know, it's something that I'm used to and something I've always used. Of course, you can use alternative web servers that are internal, such as a Python web server if you're that so inclined. Maybe I'll show that in another video. For this instance, I'm going to go for safety, something I know, and I'm going to go for XAMPP local web server. So I know that a lot of people are going to hate me for this, but you know, you're just going to have to go over yourselves. There are attackers that I've observed that also use XAMPP as well. So it's, you know, I'm not the only fan of it. It's quite easy to scan for, I guess, though. So not all threat actors. It depends on your sophistication. Mine is low, of course. That's why I'm not an attacker, I'm a defender. Cool. So we've got the web server up. I'm now going to modify the htdocs. I already have, so there's that. I want to actually, because I've been working through this, I actually want to just actually rename these. I should have done this beforehand. There we go. So this is the actual one that we're going to want. But before we do that, we need to visit that website. So that's what we're going to do. Okay, so we're just connecting to the service. This is a Telegram proxying service. And essentially, it's got some crazy stuff. It's pretty clear what we're looking at here. Which is this. This is the crazy stuff that is pretty standout, shall we say. And the interesting thing about this malware is it's got this midway point, right? So they use, I think the attacker doesn't control it, but I'm not so sure. But Raccoon Stealer has a history of using a midway point, I call it, where it calls out to a external service, and then it gets the C2 from that, and then it uses it. So it can dynamically change it. It will always connect to what is the legitimate, in quotations, domain, service, whatever. And so it will always call out to that, but it can get a new C2 if they've, you know, lost their C2 and stuff like that, so that they can, you know, retain things that normally if a C2 went down they wouldn't be able to. So it's a little bit of a more of a security option for that developer and operators. The problem with it, of course, is if you're in a corporate environment, or if you're, you know, someone who's of high worth, you'd have teams that are working against this sort of stuff. So if you've got an internal threat intelligence team, and that's what's so important, you'd understand actually Raccoon Stealer uses this service. This isn't really necessary. It's a really odd proxifying service, so we don't really need to, you know, it can be blocked. And with that, you block the actual channel for the Raccoon Stealer communication. There is no sort of backup version of this. It keeps trying to connect out to this service in this specific sample, and if it doesn't have it in a specific format, it will not work and it will not communicate to a C2. So that's really important for a defender to know that knowledge, but you would only really know that. You could put it through a sandbox and you could see that it is always connecting out, but you wouldn't understand how that was happening, and also the importance of the Telegram service. And that's why reverse engineering and threat intelligence can be really important for a corporate environment, if I'm honest, because these are the sort of things of value that you can bring to a service. Anyway, enough of me selling threat intelligence. Let's get to it. So we can see some interesting stuff here. What we want to do actually is just emulate all of this. So we want to just simply copy and paste, much like phishing people. We just want to copy and paste the source of this. We're just going to drop this into our index.php, which we've already got. So strange. What? I'm just going to copy and paste it for completion. And we can see this is the important line here. We can see there's not really, actually, to be fair, they could get it from there as well, actually, looking at this, but they don't. I've seen this already, so they get it from here. Cool. So we can see that we've copied and pasted it into our local web server. So if we go back into here, we can see a get here. If I open up IDA64 free and get the Raccoon, now I did restart the VM with issues, so this might not exactly have saved everything that I've done. It didn't. Cool. That's fine. I believe at some point either that or this is the HTTP. There we go. This is the HTTP request. Lovely. That's all I need. So when I looked at this first, you could see the get. That was obvious, but you couldn't see anything here. It was like strange. That wasn't really anything interesting. And I believe this is used. No, I've lied to myself. Fantastic. We can see in here, it's pretty obvious, it's got a HTTP request, there's a load of connect, and then open request. We've also got some strange stuff like here, the exclusive or loops, but we've got ways of looping out of that and going straight into open. Again, we've got these exclusive or strings again. Something to look out for. But we've got the HTTP request, and we've got the get. We know it's a possibility because it's so soon to what we've seen. So what I'm going to do, I'm going to step over, and we can see that our URL is still there. We see a re-emergence of that RC4 key, what we know as a key, although I'm not sure I said that in the video, but it is the RC4 key for the strings that come before it. So then we can see the RC4 call again, the E04 here. And I know what it is. It's the other one, the other base 64 string that we found, which is used here, which leads to the result of C90D. I've actually got this saved so that we can actually look at that at some point, but it's actually not too important for this video, so I'm not going to go dwell in too much. I believe that is the config ID of the malware, which becomes important when it talks to the gate. But for now, we're not going to go too much into that. We're just going to carry on. So we see the get here, and we see again the reference to our localhost, what we got from decoding and understanding the RC4 decrypt. So we're going to go further on. Something really integral we can see here already. The reference here, description der auto. If we look at description der auto, that only really happens here. And we can see what's happening really here is that they're looking for, when they get a response from the server, has it got this? And that's what we're getting from it. And if we go into IDA, that becomes a little bit clearer. So we've got the unknown chunk here, which is here. Am I right? 2C8? C8? Yeah, 2C8. So that's being dropped into EDI, and we look into EDI. That's being pushed into this, and then we've got a decision, right? We go here or here. If you look at this, we see a loop, which is really interesting. But what's more interesting is that we've got the get again, and then we've got a HTTP request again. So if you think about it logically, we've got the HTTP request, then some sort of verifier, and then it goes either way, and then a loop with a sleep. So what my theory is and what I've sort of verified is that this first gets a HTTP request, then it checks if this pattern is in it. If it's not, it goes into a sleep, and then it'll loop and check again with a GET request. And so this is what I mean by important in sort of blocking this request, is that to get anywhere near its stealer and communication functionality, the C2 has to be verified through this protocol, right? It has to go through this Telegram service, through this sample. And of course this sample could be communicated and updated, but you could kill it in its tracks, because it's been a couple of months now. Raccoon Stealer might have changed. You know, I haven't checked very recently, but last time I checked, it'd been about 4 or 5 months, and they'd used this Telegram service since. Okay, so that's pretty big for trying to defend against this threat. And, you know, this loop really does bring into some form of importance of mass defending, is that you could put into a load of endpoints, you know, block this website, and you've blocked Raccoon Stealer for a number of months, which is absolutely crazy. But what is part of it? You know, the attackers or the operators or the developers of this have decided that, you know, in a cost-benefit analysis, this for them is the best option, which is under debate. Is it? Who knows? But anyway, so with that, I looked at this and I thought that's really interesting. So this must be the pattern check, because we've got this. This here is really unclear. We can see a load of zeros. We need to see it live. We watch it live and we see it's got the pattern. So with that, we step in and we hope that it works. So we get a jump, and then we see the reference, the 319, which I believe we go back to IDA. Oh, the 319, there you go, back bottom there. We can see it, the address. So we've got the pattern check, cool, and then that will really decide what happens. I think we've got it working because, of course, we've got it here, so it should be working. So let's have a little check. So that seems to be correct. We don't have that loop which goes into a sleep. We go out onto this part here. And now we're into the interesting part, because first of all, this looks like base 64 encoded string, right? The main thing here is this, which is strange in a base 64 string, that are really killing it, right? So if we put this in as a base 64 string as a whole, which really threw me for a little bit, I'm not gonna lie, it very much threw me. From base 64, I put this. We get this gobbledygook, it doesn't make sense. So what we need to do is just look through this, and this is what's so important about live analysis. We could look into this and maybe understand it from the analysis of this, but I'll be honest, I got it quicker from just doing the live analysis and emulating the C2, and that's what's so important sometimes about emulating the C2. So instantly we get the main string here, what we can see in our analysis. So they've trimmed it down to this. It's trimmed out from the div and here. So good pattern matching. We've done it from there. Now, and we got that from the 714, which we can put to here. So filter. I'm just going to call it that for now. Cool. Now what we're going to do is we are going to step on and see if we can find any differences. So that's the more important thing, because I don't think it will. If we go further down in the IDA analysis, we see have I labeled these correctly? I don't think I have. Well, there is a base 64 decode and RC4 decrypt, which is clear once you label them correctly in IDA, but of course I do not do that. So what we'll do is, what we want to know is what's going on here, which means that it can base 64 decode correctly. So with that, we'll keep going. So we'll see here, we see the difference there is pretty clear. We saw that instantly, which was the removal of these here, DB48, and we're left with the EY. So that's been filtered out thus far. Now what we're going to do is we're going to step on further and see what happens. See, there's been a call there. What's happened? We've seen, again, something has been stripped out, and that's, of course, this bit here. So if we now look at this string that it currently has, it's this, which is pretty significant. So if we base64 decode this, we know, well, I know that it's still gobbledygook, but when RC4 decoding or decrypting it, it didn't work the other way. We can see it's filtering something, so now we need to go a little bit further. So we've got the EY. Where's the RC4? There's the RC4 decrypt. So I'm going to call out RC4 decrypt here to make it a little bit clearer. And then we've got a call here, a call here, and then we've got, so this must be the base64 decode, because of course these have been here beforehand, I believe. 73, 73. Yeah, see they've been there before. There's two of them, which wouldn't make sense for a base64 decode, while that would if it's a one singular. So we can see that it's possibly going to be a base64 decode. Right. We could confirm that, but I'm just going to continue on, because I know I've got quite a lot packed in here, and so I want to put as much out on the communication as possible. So with that, we've got this reference to 6A51DE, which is really strange, but it's actually part of what we've got in the binary. So 6A51, I had it a moment ago. There we go. 6A51DE. This is used with what looks to be our base64 decoded string. So if we go further in, we see it continually be defined, and then here, if we go into the RC4 decrypt just before, we can see some utter craziness here, which is strange. But let's test this out with a theory of just using cyberchef to test this. So if we RC4 decrypt it, what do we get? We get the C2. We get the C2 of where it's actually communicating. So I'm actually going to breakpoint here. Actually, no, we've got them both here, so we might as well do that. So I'm going to copy this and put this in a notepad. Clean this up, and then I'm also going to copy this out and put this here. And I'm going to test them out, and that's what I did beforehand. I didn't go through and verify every single base64. What I did is I just tested out a load of things. So first of all, I tested the same RC4, but then I noticed that there was this weird 6AA51DE string that was around, so this looked more likely. So with that, I'm going to put this in. I'm actually going to create a new one, so I'm going to open up a new tab, and I'm going to want that into this tab to make it a little bit clearer. This will be our base64 that we want decoded, so this will be our starting point here from base64, right? And then we're bringing that to hex, fantastic, and then we want RC4, but we don't want the previous key what we had before, which was that XOR loop. This time we're going to use this 6AA51 because that looked to be used earlier on. So instead we're going to use the UTF-8. Let's see if demos can work. And there we go. We've got, interestingly though, we've got a H there, which is new. That's new. What's happened here? Ah, I've got a 6 there. I don't know why I've got a 6, but if we look back, we had the XE, right? That stopped it. X, yeah, X. So we actually E6 there. I don't know why I don't know. I don't know why I've left that in. Let's change that up. Yep, to PHP. What can we do at this point? That's really interesting. We can change the gate. So let's change the gate to something that we can control. Again, this HTTP, we could change it with the host file, but this time we're going to just change it up. Again, using this. Oh God, Edge was there. Right, cool. So we're going to need to change the passphrase. The input is going to be UTF-8. It's going to be base64, but this time we're going to want to put gates. Yeah. And then we're going to change this to log. And that will hopefully sort us out. So we've got the passphrase set this time. The difference one that we've found out. The input format is UTF-8, it needs to be, and the output format again is base64. So we're just going to again verify it by using this, by going here. Looking at this, this is looking a bit different, which is worrying me a bit. We'll see where this goes. Is this going to work? What's gone wrong here? I've done something wrong. Ah, hex, there you go. It's different. There we go. So let's put this back here. Very important to do that. And this time we of course want the string as UTF-8. Lovely. We've verified that. Localhost gate log. Is that in a thing? It is. Lovely. So this time we need to change, not the malware, but this time the actual response that we're going to give it. So with that, we're going to go into here and we're going to modify index. So we know that we've got this in between. We know we've got this in between. This is where it's gone wrong here. I didn't notice that E6 was taken out. It is that, yeah. So with that, I'm just going to go from here, and I'm going to replace it. I'm just going to add our own. Looks kind of strange, but might work. It will work. And we can modify anything here while we're waiting. You know, there's nothing else that we need to worry about here. It is just this main line by the looks of it. So with that, I'm going to restart this, and then. Can we go further on the bullet point, breakpoint? We want, yeah, I can. We want the breakpoint here. Now, which breakpoint is that? That is the gate. Okay, so we can see here we've got gate/log.php. So we've successfully done what we were talking about while looking at that cyberchef in the second part here, where we used this as the RC4 key. We can see that it's changed and it's been able to do so onto the response that we've emulated. Super cool, lovely. I know I'm going super fast. I can go on a slower video, but for now I just want to show this as the functionality. And you know, if people find it is not slow enough and it is, you know, it's not in depth enough, perfectly happy to go further into the malware and talk about this at depth, about the filtering and trying to understand the various parts, especially at this point, because it is quite confusing. At this point, though, I am relying on live analysis, where I'm just going through line by line and looking at the routine. So we looked at that sort of filter, assumed something, and tried something, and it worked. And that's what I've done off camera, as you would normally say. So, cool. With that, what I'm now doing is, if I open up Gate and remove that, there is this particular script that I use for PHP by Magnetic Online, which is essentially, it will dump all of the HTTP request, whatever it is, be it a post, be it a head, be it a you know, whatever. It will dump it into a text file. It's just a nice little PHP script that's in a class. It's nicely done, and I quite like using it. It's worked for me in the past with malware. So what we're going to be looking at now is we're going to be looking at the final step. So if we run this malware, we'll get a HTTP request now, because we've emulated we've modified the binary at this point in the hex editor. We've modified this. We could also modify this if we really wanted to, which is the config ID. And we can also modify this, which is the second RC4 key. Again, as you can see, this is full of 20s, which means that we can modify this to a certain length to here. So it's got quite a big RC4 key length. There, what is that? What size is that? That is a 64 length. If we look at this, we've got some big lengths for config ID as well. So, you know, there's some ways that we can make it. If you want to make a builder, we can. But again, I'm not so sure about it. I'm unsure at this point. You know, this is sort of the edges of how far I would go show online publicly, free to show. But this is where we're going to now see the information come in that Raccoon Stealer would bring at the initial point, right? So if we step in a little bit further, and before we do that, we just go a little bit. We are at this point around here where we'd be at the get username A, which would be, you know, looking at the information, the standard starting point. So we've got this again, XOR loop standard, and we'll start to see the format of Raccoon Stealer's HTTP protocol and the way that they communicate, right? So we can see bot ID. That one's pretty standard. We can see it's going to get my username, so we can start to learn and understand that. And then we're going to see a call here that is called this, which is an environmental, unique environmental value. So I'm not going to go too much into that for now. We could go further, of course, but for now I'm just going to call it a unique environment variable. And then from there, we're going to go even further, and we're actually waiting on the point where it's got another HTTP request. So we can see here we've got this decision here where we can go and do these weird loops here. The actual decision we're looking for is this post here. We're interested in this post. So when analyzing this, this is the final point. I want to know what's going on at this post. So we've got a loop here. We're at get username A at this point. So we're going to go through here, go through this loop, which is really aggravating to view. And eventually we should, if we don't do anything wrong, we should be able to get to this HTTP request. So with that, that's where I want to enter and end the video, is showing that. So we'll go through this. We can see it will probably concatenate the strings. It will probably use a number of parameters. So the next one here looks to be another parameter. So what I'm going to do is I'm actually going to just breakpoint here. Skip that. We can see config ID, which is what I've already previously talked about. I already know about it because I've analyzed the malware. But this is the what we had as the second base64 encoded string, not the one that was the telegram, but the other one, which will be concatenated, and we can see here, which was the 627 was a concatenation. From there, we'll get the third parameter, which I actually can't remember. Data, yeah, so further things, and I think this is where, you know, you'll have the standard bot ID, what it can identify, the config ID, which will be used, I think, if I remember correctly, for the RC4 communication between the C2 and itself. They're unique, and that's why it needs to be sent, to make it a little bit harder for network signaturing. The problem with that is that they've got a fail point with the midway point. That's the problem, that their main thing is that defenders can just block that. And then we'll go on to the next part, which is null. I'm assuming that decision is down to the fact that this is the initial gate response request. And then we'll go forth into the HTTP request. We see that. Now that is the base64 encoding of that, which we can verify in a moment. But we see the post. And if I just verify what is the 299 is the post. So we've got 3299 is the post. We can see the gate and the log here, which gives us confidence. So what I'm going to do is I'm going to step through, step. We could verify this through a memory viewer, like Process Hacker, but I'm actually just going to go through. Now with this script, we want to see dump requests. So if we see dump request in the directory, it's been successful. It has sent us one. We can see that 7 a.m. It's 7 a.m. in the VM. So let's edit it and let's have a look. So we've got a post. We've not got anything else like a user agent or anything else like that. Nothing fancy. But with that, we've got params equals, and this is the full line. So if we verify this in cyberchef, have we just got? Yeah, we have here. So if we just put that in there, ooh, what's going on there? There we go, strange. So with that, we've got the bot ID, we've got the config ID, and then data null. That is the starting point for the raccoon stealer in their initial gate. So you can emulate that. You can create, your own sort of patterns and understand it. Pretty standard, easy sort of look. And actually, if you've got a load of raccoon samples, which we could do in another future video maybe, give me a comment down below what sort of future video you want. We could continue the raccoon stealer series. There's, we could go back to decryptor and look at that, or we could look at, possibly doing a builder. I could do that maybe, or we could look a little bit into identifying a load of samples, me getting a load of different samples and trying to identify, patterns and defending and that real interesting theory. But at this point, I want to leave it at that. The main thing I wanted in this video is to show the communication and how you can modify binaries to really sort of make and modify the malware for your own analysis means. And so what we've done is copied and pasted from the attacker, understood the protocol completely at this point in this stage, so with the gate, where we can modify it to sort of understand the initial steps that raccoon stealer would have before they would start transferring or exfiltrating the stolen data. So I hope that really was fun. I know that was quite fast, but I thought that fitting that in a video, either I would have to go fast or it would have to be really slow in a sort of 2-hour, 3-hour video. So I think that is something that I wanted to show. Hopefully it was interesting. Give me a comment down below if you enjoyed, and I will hopefully see you guys in the next video.